Now assembly drawings, standard parts. Some parts are standard which are used in assembly. Now what is standard parts? Standard parts include any part that can be bought off the shelf. We can directly purchase from the market, and special design consideration is not given to that component. In designing, suppose the diameter of bolt we need to use is 29 mm, we will not write M29 bolt, we will use M30 bolt because M30 bolt is readily available in the market. They do not need to be drawn, not needed to be drawn, the standard parts. Purchasing information is given on the standard parts sheet attached to the back of the working drawing package, means the last sheet which shows the details of the standard parts. This is a typical example of standard parts sheet. You can see here number 9 is a compression spring, diameter 8 mm, ID length 46 mm, 0.4 wire diameter, 12 coils are there, 5120 steel is the material, and quantity required is 1. So this is the part name and part number is 9. This is written. Drawing is not compulsory in this case. Just this data is written. It means that we can directly purchase this material from the market with this specification. Number 10 is plain washer. This is also standard part. You can see here the specification of plain washer is given here, 7.2 by 16.1.7, and material is 1115 steel. Quantity required is 1. So information needed to purchase the item is enough. Number 11 is M8 hexagonal head cap screw. These are the details, and with these details these also can be readily bought from the market, or they could be readily taken from the shelf. Then number 12 is a spring pin, diameter 2, outside diameter, length is 14, double size, and quantity required is 1. So this is a typical example of standard parts sheet, and this sheet is to be put at the last of the drawing package. Now what type of information should be included in standard parts? General fastener specifications. Fastener is also a standard parts. In general fastener specifications, the first is thread specification for threaded fasteners. Second is name of fasteners, then head or point style or shape if applicable, then fastener length or its size, then fastener series, material of the fastener, and special requirements, for example coating, finishes, specifications to meet, if any is there, they should be mentioned in the specification. On required quantity, that is number of required, 1, 2 or 10, or how many components are needed, they should be mentioned over here. Bolts and nuts specification. Thread specification contained in the thread knot, style of head and name of the bolt or nut, length of the bolt, these all are nuts and bolts specification. Then material, then special requirements, so for example coating, finishes, specifications to meet, and required quantity, how many number of pieces are required, they should be written in nuts and bolts specification. Now working drawing package 1. What's working drawing? What's package 1? You can see here. Draw an assembly drawing of the trolley shown over here. Draw detailed drawings of the individual parts. Create a standard parts sheet. This is one example. you have to do hands-on exercise for this component. Assembly drawing for this component is given to you. You draw individual components, detailed drawings, and 2 or 3 views of assembly drawing of this component. Next, you can see here. I hope you will be able to draw these 3 views of these 2 pulleys, hexagonal bolts. This is a base, 2 supports, bearings, shaft, and these rings. Fill in the part numbers in the appropriate balloons. Now one more exercise. Complete the parts list and title block information. Here half work is done. You have to complete the remaining works. You insert the dimension numbers 1, 2, 3, 4 and so on, and write appropriately here the name of component, quantity and material required to produce that component. These are the numbers, starts from 1, 2, 3, 4, 5, 6, 7 and so on up to 12, and this is the part list of that component. So number 1 is trolley wheel. This is number 1, that is trolley wheel. 2 wheels are required, so quantity 2. Material is steel. Number 2 is side plate, 2. Number 3 is crosshead, 1. 4 is axle, 2. 5 is adjusting seam, 2. Keeper plate, 2. Number 7 is ball bearing, this one. Number 7, this is ball bearing. 2 bearings are required. Number 8 is this one, that is axle snap ring. Number 9, it is here. This is number 9, which is called as wheel snap ring. 4 rings are required. Number 10 is 7 by 8 hexagonal head bolt. Now what is this 7 by 8? In a local terminology, 7 by 8 means 14 upon 16. 16 means 1 inch. So 14 parts of 1 inch, that is 7 by 8. If we divide 1 inch into 16 parts and consider 14 parts, that is 7 by 8 or 7/8 inch, that is hexagonal head bolt diameter. Then hexagonal head nut, number 11. Number 12, plain washer, and number 13, round make SCR. So that is the bill of material for this case. For this example which we taken earlier, list of components and bill of material, assembly drawing of that component. Draw the missing sectional view and complete the title block information for this case. Here you can draw the missing sectional view. For that, half exercise is done over here. Dotted lines are drawn. Just you have to fill up which lines should be drawn, which will be visible and which will not be visible. You can do this exercise at your own. One another example of assembly drawing having section lines. Answer of this previous question, this one. If we solve this case, this is the answer of that problem, which is drawn over here. You can see here. Here material is cut, so section line is drawn. Here material is not cut, circle is there. But yes, what will you do if there are 3 circular holes? You can see here 1, 2 and 3. If you cut this, then here a hole may not be there. If you cut it straight away, here hole may not be there. So in that case we have to use this cutting plane, inclined cutting plane. This is a divided cutting plane. For example, this cutting plane starts from here, it penetrates up to center, and after that, that cutting plane should be drawn in such a way that it passes through another hole from here. it is passing from this hole, and hence we can draw this side view in this way. In both these circles or both these holes are visible in this view, and this is important in case of where the odd number of holes are there. If here even numbers of holes are there, it may not be needed, but as 3 number of holes are there, we need to draw this kind of inclined plane and cutting plane. Now place the remaining 6 dimensions and complete the title block information. One more example to you. Place the remaining 6 dimensions of this example. It could be done. This is the solution of that problem. All the dimensions are inserted. This is the isometric view of that drawing, front view, and this is the side view of the drawing. Place, now one more example, place the remaining 9 dimensions and complete the title block information. Here 2 views are given to us. This is isometric view, and remaining 9 dimensions could be placed like this. These all are the dimensions which we have inserted in this assembly, and from this we can reproduce the same drawing. One more example, draw the missing dimensions and complete the title block information. Here missing dimensions are this one, you can see here. Here these dimensions are not there, this gap, this length, so we insert all these dimensions which are inserted over here, and it is redrawn. So that is the solution of that problem. Draw the dimension part number 5 and fill in the title block. You can see here, this is a component, and this is the front view of that component, and this is the side view of that component or top view, and this is a thick component having thickness 0.12, so only one view is enough to understand the details of this component, and in this component insert the dimensions as shown over here. Draw and dimension part number 6 and fill in the title block. This is the part. So these all are the individual parts that we have drawn after disassembling the component which we seen earlier. This is the detailed drawing of that part. This is isometric drawing. We need not to draw this isometric drawing in the examination, just we have to draw this detailed drawing. Now complete the information on the standard parts and fill in the title block. You can see here, these are the components of that assembly having the standard size. These all are standard parts, 7, 8, 9, 10, 11, 12 and this 13. So this is a departure ball bearing, hexagonal head bolt, hexagonal head nut, washer, round head mag screw and so on. Axle snap ring number 8. This is axle snap ring which is used to snap the axle. It reduces the alignment or gap between the mating parts. Wheel snap ring which is used between wheels. It could be inserted without disassembling the shaft. Now next exercise, working drawing package 2, example number 7.3. Draw an assembly drawing of the drill jig shown. Here drill jig is shown. Draw detailed drawing of the individual parts. Create a standard parts sheet. So here we will draw individual component one by one. We can draw its front view and side view from given dimensions. These are the 2 views. Complete the sectional views by adding this appropriate section lines. So here we have drawn 2 views, front view and top view of that assembly. Here bill of material is prepared. Then method of projection method symbol is drawn over here, that is third angle projection method. After drawing these 2 views, these sectional views, if we draw section lines, if we cut that assembly, the material will be cut as shown over here, shown by these section lines. Now fill in the part number in the correct balloon, the parts list and title block. So part number 1, 2, 3 and so on. They should be filled over here like this. All are filled 1, 2, 3, 4, 5, 6 and name of each parts. Number 1 is base, this one. Number 2 is end bracket. Number 3, that is center plate. Number 4 is this hexagonal head bolt, specification M20 by 2.5. Number 5, head screw, flat head screw. Number 6, hexagonal head nut. This one, this is a nut. So these are the 6 component. This is bill of material, part number, part name, quantity required and material used. And this is the top view of given assembly. Right? Now after drawing this detailed drawing, assembly drawing, let me draw detailed drawing of each component. Number 1, what is the tap drill size for M12 1.75 thread? Insert that size over here. So this is the detailed drawing of tap drill size M12 by 1.75, that is 10.3. How much further does the tap drill depth proceed past the thread depth? That we should compute from the assembly drawing, and appropriately we can draw in the views. So I hope we have discussed the things today which are important to us. These are the important websites through which you can get more materials regarding these matters. So I hope today's discussion would be fruitful to you, and you might have learned about how to draw detailed drawings, how to draw assembly drawings, what are the importance as far as industrial aspect is concerned. Thanks to all of you for being with me. Thanks to all.